This video is for my pre-algebra classes and is over lesson 29, ratios. So ladies and gentlemen, a ratio is a comparison of two numbers using division. So for example, if I have a class of 6 girls and 12 boys, then we could say that the girl-boy ratio here is, well, take the number of girls first, 6, to the number of boys, 12 second. Now there are three different ways that we typically write a ratio. One is what you see here with the word 2. Another way is with a colon. And since this is a division relationship, we can also write ratios as fractions. And when we write it like a fraction, it gives away the fact that just like fractions, we can reduce our ratios. So 6 can go into both 6 and 12, making this a ratio of 1 to 2. Which means I could reduce this likewise, dividing both of these by 6 to create a ratio of 1 to 2 like that, or like that. If we switch over to looking at the boy-girl ratio, then instead we're looking at the boy number first, followed by the girl number. Well, we've already reduced these. I know that my girl number is 1, my boy number is 2, so just switch them around. Boy number 2 first to my girl number 1. So we see here that in this class, the boys outnumber the girls 2 to 1, which means for every 2 boys, there is 1 girl. Or if we look over here at the girl-boy ratio, for every 1 girl, there are 2 boys. They mean the same thing. So likewise, I could write this with a colon, or I could write it as a fraction. Now, as a fraction, we would leave that as 2 over 1 as a ratio of 2 to 1. With one exception. Occasionally, we do make our ratios into decimals. So 1/2 obviously would be 0.5, and then 2 over 1, well, would be 2. It would be a whole number, and that counts, even though it doesn't have a decimal in it. It counts because we were willing to make a decimal if necessary. However, this is unusual. We don't usually make them in decimals. However, if I do make it into a decimal, this feeds nicely into making an equation of our situation. So since this is the girl-boy ratio, I take the girl first. I'm going to do G for girl. And this would equal my ratio decimal, 0.5, times the second number, the number of boys. And now we have a little equation for discovering the number of girls. Likewise, if I did it over here, this time the boy number is first. So boys equal my ratio number, and then followed by girls. Now, in a normal ratio, just a plain old normal ratio, one of two things usually happens. Either units cancel, and so we could see that in the sense of, well, what is a girl? Well, a girl's a type of human being. What's a boy? Another type of human being. So you have human beings over human beings, and that would cancel. Or, so the units cancel, or are in the name of the ratio. So instead of saying 6 girls and 12 boys, or 1 girl and 2 boys, we know this is a girl-boy ratio, and so we don't need to mention it down here. So either the units cancel, or they're in the name of the ratio. So a ratio with uncanceled units, so units that are still there, that they're not going to go away, is called a rate. And let's go ahead and grab our yellow here, and we'll come up and highlight ratio. We'll come down here, we'll highlight rate, and then I want you to underline this. So if we still have units in our ratio, we call that a rate. And rates are set up as a number followed by the first unit, then per, and then the second unit. So typical examples of rates would be if you're driving to school and you're going through your subdivision, you might see a sign that says 25 miles. And then for per, we often use a slash per hour. Now in my class, I ask you not to use the MPH there. I prefer the slash. I have my reasons, but let's put the slash in. So 25 miles per hour would be a rate. Or let's say you are draining your pool at the end of the season, and you're draining it out 3.5 gallons per minute. And I don't own a pool, so I have no idea if that's fast or slow. That seems like a decent speed to me. But again, I don't have a pool. Or let's say that you're traveling along in the car at 0.4 kilometers per minute. Or you're in computer class and you're typing 45 words per minute. Or we're lining up at recess and we want there to be 20 people per line. These are all rates. Now remember that a rate is a ratio, and a ratio is a comparison of two numbers. And you can very obviously see one number in each of these, but where's the other number? Well, when we use per, we have a hidden 1 in each of these. So this first one is really 25 miles for every 1 hour, 3.5 gallons for every 1 minute, 0.4 kilometers for every 1 minute, 45 words for every 1 minute, 20 people for every 1 line. So we always have that hidden 1. You're not going to see per, it's not going to say 25 miles per 2 hours. That's not something we do. That is not something that we do. So we're going to take a look at how to use rates in a problem. And we're going to make a little chart. We're going to start with a rate. And for our first rate, we're going to go with our first example there. 25, and I want to make this double big. I want you to make this double big as well. 25 miles per hour. And I'm going to put an equal sign here. And this is where we're going to put our second column for our chart. We're going to turn this into a fraction. So rates being a division relationship, being a ratio, we should be able to turn them into fractions. So I'm going to start with the number 25. 25 as a fraction would be 25 over 1. Now my units also need to be turned into a fraction as well. And so if you imagine this slash for per just getting twisted, and so that miles will get thrown up top, the hours will get pushed on bottom. And so 25 miles per hour is really 25 miles over 1 hour. So let's skip a space there, and we're going to do 3.5 gallons per second. Let's switch it up to seconds here. So if I have 3.5 gallons per second, 3.5 gallons per second, again, start with your number. Now this being a mixed number, I can't just throw it over 1 because I don't want to have a fraction inside of a fraction. So we want to remember to think about using the u, and I'm not going to actually draw my u in here, but think about that u that changes mixed numbers into improper fractions. So 3 times 2, 6, plus 1, 7. So this is 7 over 2. And then again, imagine that twisting over to make a fraction. The gallons would get pushed up top, the seconds would get pushed on bottom. So this is really 7 gallons over 2 seconds, or 7 gallons for every 2 seconds. All right, we're going to take a look at one more. And so this one will be 0.4 kilometers per minute. So being a decimal, I'm going to change this into a fraction just like I would do with any other decimal. But I don't need to worry about reducing it right now because of what we're going to be doing next with it. So I'm just going to leave it unreduced. So remember, for decimals, you imagine, okay, if I were to say this in words, this would be 4, and it's in the tenths place, so this is 4 tenths. So literally 4 tenths. Units then, kilometers would go on top, and then the minutes would get pushed to the bottom. So this is 4 kilometers for every 10 minutes. Now, ladies and gentlemen, if you can do this with your rates, then you're ready for the next part of this. And that's that we take rates and we use them as unit multipliers. Now remember that unit multipliers are two things that are equal on top and equal on bottom. So normally this would be something like, if I look at my dry erase board here, normally this would be something like 1 foot over 12 inches because 1 foot is equal to 12 inches. Or it might be 12 inches equal to 1 foot. I can flip it over and these two amounts are still the same. And since they're the same, this is a form of 1. So it will not change the value of the number, but it will change the look of the number. Well, rates give a special exception. Now, normally you could not change hours into miles or miles into hours, but this rate here, at least for whatever context this is in, gives us a connection between a certain number of miles traveled and a certain number of hours traveled. And so we can use that as our unit multiplier. And just as I did on my dry erase board, these always come in pairs. The first one of the pair will just be your rate as a fraction. So this will be 25 miles over 1. This will be 7 gallons, or excuse me, 1 hour. This will be 7 gallons over 2 seconds. And this will be 4 kilometers over 10 minutes. So as long as you can change your rate into a fraction, you've got the first unit multiplier. The second one is even easier because we just take the first one and flip it over. And so this would be 1 hour over 25 minutes. This would be 2 seconds over 7 gallons. And this would be 10 minutes over 4 kilometers. And so we'll take whatever it is we're trying to change and multiply by the appropriate unit multiplier to get the units we don't want to cancel and the units we do want to stick around. So we're going to take a look now at an example. So let's say we're told there are 20 people per line. So that was one of our examples on the front. Well, if there are 20 people per line, if we turn this into a fraction, this would be 20 people over 1 line. That would be my first unit multiplier. My second one, then just flip it over. 1 line for every 20 people. So what I'd like you to do is skip a line here, and then let's put in an ellipsis. Okay, this is going to mean go back up to the top, and we're continuing from there. So continuing from this, there are 20 people per line. If there are 60 people, how many lines are there? So if we think about the question, we're saying, how many lines? We don't know how many lines. Well, what needs to lead to this unknown number of lines? Well, it's going to be 60 people that's going to lead to this unknown number of lines. So we're really asking 60 people makes up how many lines? So when it comes to unit multipliers, ladies and gentlemen, remember to take what it is we're trying to change. So in this case, the 60 people, and we're going to turn that into a fraction. And usually that's just going to be a matter of putting it over 1. Now we're going to multiply by the appropriate multiplier. Now we've got our 2 multipliers up here. Since I have people in the numerator, then in my multiplier, I want to have people in the denominator, so that people and people will cancel. So it's going to be the second unit multiplier, that the 20 people is 1 line. People on top cancel people on bottom. 20 people per 1 line. Now I see I got a 60 and a 20. I can reduce. So that becomes a 3. That becomes a 1. All 1s on bottom means this is a whole number. So 3 times 1 line is 3 lines. If there are 60 people, we will have 3 lines. Now skip a couple lines here, and we're going to do another ellipsis. So this ellipsis again is saying go back to the beginning. Go back to the beginning. So there are 20 people per line, but this time I want to know how many people are in 60 lines. So this time I know I have 60 lines, but I want to find out how many people is that. Take your starting amount, make it a fraction. So 60 lines over 1. Now this time, since lines are on top, I want lines to be on bottom. That's going to require this unit multiplier, this first one. So 1 line on bottom, 20 people on top. And so lines will cancel lines. Well, line, that should be singular because it's just one of them. But same idea. Line will cancel lines. And I'm left with people. All 1s on bottom means that this will be a whole number. So we multiply. 60 times 20 is like 6 times 2 with a couple extra zeros. So that's 12 with a couple extra zeros, comma, people. Oops, forgot the E. All right. Last thing, let's say that we have a school of 789 boys and 597 girls. If I asked you here for the boy-girl ratio of this school, well, we take the boy number first, and I'm going to write this as a fraction this time, 789, and put it over the girl number second, 597. The issue with this, though, is this is a really awkward ratio that if it can be reduced, it's probably not going to reduce super nicely. And so in a circumstance like this, it could be appropriate just to make this more pragmatic, more useful, to say that this is approximately equal to and round these. So 789 would round to about 800. 597 would round to about 600. And then, of course, 200 can go into both of those. Goes into 200 goes into 800 4 times. 200 goes into 600 3 times. And so I could get a approximate ratio of 4 to 3. Now, this would mean for every 4 boys, there are, and since this is only approximate, there are about, since we got that about there, that approximating to it's going to be about 3 girls. And that, ladies and gentlemen, is the end of our lesson.